Hello guys, welcome back to AI with Radhe. Great to see you here. Keep learning, keep growing, and keep coding. In this video, we're going to explore some super important Python basics. Let's jump right into the topics we'll be learning today. Variables and data types, strings, basics and operations, numbers, math operators, input and output, I/O, type conversion, casting, comments and code documentation, working with Python modules, errors and debugging basics, Python operators, logical and comparison. In Python, variables are like small memory boxes where we store information. Each box has a name, and inside it, Python keeps a specific type of data. For example, the variable age stores an integer like 20. Price holds a floating point number, which is a decimal value. Name stores text, what we call a string. And active stores a Boolean, which is either true or false. These data types help Python understand what kind of information it's working with, and how that information should behave when we use it inside our programs. Strings in Python represent text, and one of the coolest things you can do with them is slicing. Slicing lets you take only a part of the string by selecting specific index positions. Here's an example with the word radhe. Each letter has an index starting from 0. So when we write radhe 0:3, Python returns the characters from index 0 up to, but not including, index 3. That gives us the slice rad. String slicing is a simple but powerful way to extract the exact text you need. In Python, numbers are used for all kinds of calculations, and math operators make those calculations simple. Addition lets us combine values, multiplication repeats a value, and division breaks it into equal parts. Subtraction works just like regular math, taking one value away from another. For example, 10 plus 5 gives us 15, 4 by 3 results in 12, and 20/4 gives us 5. These basic operators are the foundation for all kinds of mathematical logic inside your programs. In Python, input and output let your program communicate with the user. When we use the input function, Python pauses and waits for the user to type something. That value gets stored in a variable, like name in this example. Then, with the print function, the program sends information back to the screen. So if the user enters their name, Python responds with a friendly message like, "Hello Radhe." Input goes in, and output comes out. That's the basic flow of I/O in Python. Sometimes in Python, we need to change one data type into another. This process is called type conversion or casting. For example, int 10 takes a string and converts it into the number 10. Float 5 turns a string into a decimal value. And str 99 converts a number into text. Casting is helpful when your program needs a value in a specific format, like turning user input into numbers before doing calculations. It's simply transforming data so Python can use it the way you need. Comments are one of the simplest ways to make your code clear and easy to understand. They don't affect how the program runs. Python simply ignores them. But for anyone reading your code, including your future self, comments explain why something is written a certain way. A messy block of code becomes much more readable when you add short notes like, #this is a comment. Good documentation turns confusing code into clean, organized logic. It's a habit every programmer should build from the beginning. Python modules are like ready-made toolkits that add extra features to your programs. Instead of writing everything from scratch, you can import a module and instantly use the functions inside it. For example, when we write import math, we unlock powerful math tools. Calling math.sqrt 25 then gives us the square root of 25. Modules help keep your code cleaner, shorter, and more powerful, because you're plugging in features that Python already provides. Errors are a normal part of programming, and debugging is how we find and fix them. Sometimes your code tries to do something impossible, like converting the text ABC into a number. That causes an error, and the program stops. But with a try, except block, we can catch the problem before it crashes the program. In this example, Python tries to convert the value, and when it fails, the except block handles it and prints error detected. Debugging helps us understand what went wrong and gives us the tools to make our code stronger and more reliable. Logical and comparison operators help Python make decisions. They evaluate conditions and return true or false based on the rules. For example, true and false only becomes true when both sides are true. True or false becomes true if either side is true. And not true simply flips the value to false. These operators are the backbone of decision-making in Python, allowing your programs to compare values, check conditions, and control what happens next.